Okay, so this is going to be our review on simplifying square roots. If we're trying to simplify the square root of 28, we need to try to think of a multiple of 28 that has a perfect square in it. You know, there's 1 times 28. We don't want to do that one. There's 14 times 2. Those are multiples of 28, but neither one of those numbers are perfect squares. So the one that works for 28 is 4 times 7 or 7 times 4. Where 4 is our perfect square. We can rewrite that as the square root of 4 times the square root of 7, and we can take the square root of 4, we can't 7, and that leaves us with 2 square root 7. If we look at the square root of 18, the multiple that with a perfect square in it that works for square root of 18 is the square root of 9 times 2. Then we can break that down to the square root of 9 times the square root of 2, and we can take the square root of 9, that gives us 3, and we can't take the square root of 2, so our answer is just 3 square root 2. Now, especially as the numbers get bigger, there are all kinds of multiples of numbers, and there's a bunch of multiples that will not work. You need to make sure that you have a multiple with a perfect square in it. For example, I could rewrite the square root of 18 as the square root of 6 times the square root of 3, but neither one of those numbers are perfect squares, so I'm stuck. So I need to start all over, if I did this, and try to think of one that does have a perfect square in it. This does get more difficult as the numbers get larger. If you're struggling with this, number one, you need to review your perfect squares. You need to know your perfect squares. If you don't, you're going to struggle with this. If you do know your perfect squares, it might be a good idea for you to list them, and when you're trying to think of a multiple of 75 that has a perfect square in it, you can look at all your perfect squares at the right and try to see which ones will work. Of course, excluding 1, because 1 times 75 works, but it won't simplify your square root. 4, there's nothing times 4 gives me 75, 9, 16, but when I look at 25, 25 times 3 gives me 75. So, I can rewrite that as the square root of 25 times 3, and then I can rewrite it as, I went straight to my answer. Square root of 25 is 5. My answer is 5 square root 3. Now, so if I do it again using the square root of 32, and I go through my perfect squares, I can see that, of course, exclude 1, but 4 times 8 is 32, but if I keep going, 16 times 2 is 32. If I have multiples that have perfect squares in them, I should use the larger one. So I'm going to use 16 times 2. Then I can break that down to the square root of 16 times square root of 2, and my answer is 4 square root 2. Now let's say that I did not realize that 16 times 2 is 32, and I use 4 times 8. I can use 4 times 8. A lot of people end up with the wrong answer here because if they think they do this one time and they're finished. So let's just go through the math and kind of look at how it works. If I simplify completely, then I should get my same answer as if I use 16 times 2. When I simplify the square root of 4 times 8, I will end up with, the square root of 4 times the square root of 8, which will give me 2 square root 8. Now, I didn't get the same thing as 4 square root 2, and this is one of the things you need to be making sure that you do. The number in the radical should be completely simplified, meaning the number inside the square root should not have a multiple in it that has a perfect square. So when I look at 8, I could technically rewrite 8 with a multiple as a perfect square in it. So I could say, 2 square root 8 is 2 square root 4 times 2. So it's not completely simplified, and I just need to keep going. So if I use the smaller multiple with a perfect square in it, I can still get, I can still completely simplify it. I can still get the correct answer. It just ends up being more work. So I have 2 times the square root of 4 times 2, which breaks down to 2 times the square root of 4 times square root of 2. The square root of 4 is 2, so I have 2 times 2, square root of 2, which is 4 square root of 2. So I can use a smaller multiple, it's just more work.